Assalamu alaikum my viewers. Today is my topic about conversion of number systems. As we know, number systems have four types in common. 1, 2, 3, 4. These types, as you know, are binary number system, octal number system, decimal number system, and hexadecimal number system. Decimal number system. As these are four types of number systems, and today we learn about the conversion of these number systems like binary to octal and decimal hexadecimal number system. First of all, for this purpose we choose binary number system. First of all, we convert binary number system it is done by outer value to decimal number system. Binary to decimal number system. First of all, you learn. It's so simple, as you know. If we take an example of 1001, this is in binary form. As we know, binary is in a form of 0 and 1, and we have to convert it in decimal form. It's very easy. We have to move from right to left for converting binary to decimal. And how we have to denote each of these numbers, binary numbers, by 2 power something. Like this will become 2 power 0 multiplied by 1, first from right to left, then added to next value. 2 power increases by 1. 2 power 1 multiplied by 0, then also addition 2 power square incremented by 1 multiplied by 0 again, this 0, and addition 2 power cube multiplied by 1 last. These now we have to simplify simply like this. 2 power 0 in binary number system means 1. 1 into 1, of course 1. Addition 2 power 1 means 2, but it is multiplied by 0 and this becomes 0. This also becomes 0 as 4 into 0 plus 2 cube, it's 8, into 1, it's 8, like 8 plus 0 plus 0 plus 1. 8 plus 1, it will become 9. It is simply seen that this binary is equivalent to decimal in number system is 9. And if we have a problem like decimal point problem, if decimal comes in the binary number system and we don't know how to convert this binary number system with decimal point to decimal number system, we will take like example 0 1 1 after decimal number system. Now this is full binary form. We have converted this portion firstly. Now to convert after decimal portion, we have to point out like decimal or not. If it is not compulsory to point out decimal here, but now it is converted from left to right. This was from right to left, and this is converted to left to right. Here the initialization value of 2 is 0. Here we choose like this, 0 multiplied by 2 power minus 1, 0, it is decremented here, addition, and now 1 into 2 power minus 2 plus next last 1 into 2 power minus cube. Now after simplifying this will become 1 by 2 into 0, it will become 0 plus 1 by 4 and plus 1 by 8. We have to positive value. To get positive value, we have divided it by 1 by 8 like this. Now after simplifying and taking LCM of that values, we have 3.8. Now 8 is ignored and we write 3 as decimal number system, and then this decimal point binary number system is also converted to decimal number system. See, it's very easy. If you don't have decimal, you have to simply solve like this, these steps after the band. And if you have also decimal point in your problem, you have to solve like this to gain answer like this. Now as you see, the next step is to convert binary to octal. Let's take octal now. Binary number system to octal number system, which is octal is 8. Okay, we have to convert binary to octal number system. We have to take any example, like if we take a large example like 0 0 1 0 0 1 0 1 0 point 0 0 1 0 1 0. In this, decimal point doesn't changes the solution of binary to octal number system. For simplifying, it is all the way same after the decimal, before the decimal. It has been just like that. We have to make pairs from right to left in it, after the point or before the point, but start from here. Three pairs, each pair of 3 we have to make. There are 1 2 3 4 5 pairs of 3s. Why we make 1 pair of 3? Because as we know that 2 power 0 is 1, as I told you earlier, and 2 power 1 is 2. 2 power square is 4. So this will, if we take 2 power cube, that will become 8, and 8 is also octal, so it is not take. And this simply conversion is take before because 4 is smaller than 8 like this, and we have to make 3 pairs from knowing that it will make 3 pairs. Now we have to simply add C0 0 into 1 0, and this 2 1 into 2 2. This will become 2, and this will become 4 will become also 0 after multiplying by that. 1 will become 1 also. Then we have to simply solve like this each answer of this. Its answer is 0 multiplied by 1 0, and 1 multiplied by 2 2. So we write 2. 0 multiplied by 4 0. Now this 1 multiplied by 1 1 0 0 0 0 point. Now like this is like this matches like 2. 1 multiplied by 2 is 2, and now this is like that. 1 multiplied by 1 is 1. 0 0 is always 0. 0 is not written there, and like this is also 1. This will be our binary number system converted to octal number system. Now for next step is now moving to the third conversion, which is from binary to hexadecimal system. It's very simple. And one thing I forgot you to tell about this, in this conversion binary to octal, it's like this answer. If you not get in order to confuse by my that calculation, is simply like this. Now towards binary to hexadecimal system, it's also like this. If we take power of 2 0, it will be 1, power of 2 is 1, it will be 2, power of 2 will be square, second square, it will become 4, power of 3 will become 8. Now power of 4 will become 16, and hexadecimal number system is also 16, divided by 16, so it is not taken. Now in binary to hexadecimal conversion we will choose 4 pairs of each. Now we see any example like 0 0 1 1 1 0 1, and it's just enough, or no, we add some more digits. 0 0 1 0 1 point 0 0 1 0 1 1 0 0. Now it is, if we see, it's simply a binary number system this, but if we have to convert decimal number system also, decimal with point binary to it's so it's very simple. We have to take simply like we have taken upper third 3 pairs, we have to take here 4 pairs of each. 4 4 4 and last 4. 1 2 3 4 5. Here is also 5 pairs like upper question. Now we simply see that 0 multiplied by 1 is 0, 0 multiplied by 2 is 0, 1 multiplied by 4 is 4, and 1 multiplied by 8 is 8. So we add these values. 1 multiplied by 4 is 4, and 1 multiplied by 8 is 8. So 8 plus 4 is 12. We have answer of this is 12, and this all 0 and 2 1. So this will become 2 point, and now this will become 2 plus and no 1 plus 4, so this will become 5, and this pair will become 2 into 8, 2 into 8, wait a second, 0 2 0 8. So this will become, this will become 8 into 10, and this will become 1 into 1 and 1 into 2, 2 plus 1 3. So it's simple like that. This answer, this and this. So we simply write now answer is like 3 10 5.212. Now it is converted into decimal number system, but see here, the 10 is denoted by a in hexadecimal number system, so this is answer is invalid. We have the new answer which is correct will becomes, and 12 is denoted by C, so here answer will become 3 10 is denoted by A, 3A 5 dot 2 12 is C. So this is converted binary form into hexadecimal. This is a correct conversion. Now let's talk about the, as you see that binary conversion into all these types. Now we choose decimal conversion into all other types. Now let's see them. As now viewers, we have moved on decimal conversion into binary, and decimal into octal, decimal into hexadecimal conversion. I have simply created these notes to save your time and also mine, to feel easiness, and I can also explain you easily like following. Now we have seen decimal to binary number system conversion. If we simply convert decimal to binary conversion, not issuing that point is taken decimal point, we have simply like this. If decimal, it is converted to binary number system just like that. 12, we take LCM. by 2 each time, by 2, because binary is denoted by 2. So let's take LCM by 2. 2 6 are 12, remainder is 0 because no remainder left, we write 0. And 2 power here also 2, we write 2. 2 3s are 6, here also 0. And 2 1s are 2, here remainder 1 also left, so we write 1. And we have to write in now in binary form it is, so it is also, written just like from here, started from here to the end here. So we write 1100, as we see 1100. It is simply conversion of decimal to binary without any decimal point. Okay, if we have issue of decimal point, now we have to simply convert like this by multiplying of the of values after the decimal point by 2, multiplying, yeah, by multiplying the values by 2. Okay, now we see 2 is multiplied by this value, the answer will become this. So last value, like 2 6 are 12, 2 is written here and all these things. So like when the remainder comes at the end is 10, we will put like, after seeing that decimal point is after one digit here, so we will put like point after one digit here and choose 1 here because it's 0, and also we have taken remainder as 1 here. Then again multiply by 2, we multiplied several times by 2 until the repeated answer like this or like this will not come. We have to multiply. If a repeated answer is not coming, we will stop converting, and after 2 or 3 tries. Now this value is multiplied by 2 again, and we have value this 0 1 8 1875. So 0.0 we have written because here nothing to be after the point, so we have taken 0 as remainder. Now again multiplying after that will become 375. So 0 we have taken remainder 0 again. So after some tries we will write the values after the decimal point, as see the question is 0 point this. So in binary also we write 0 point after the conversion. We have start from here, selecting all the way down there, 1 0, all the reminders down there, 1 0 0 0 1 1. So we have written 1 0 0 0 1 1. So it is seen that it is normally converted decimal into binary form. Now from decimal to octal form, if we have to simply convert decimal number like this 484 into octal form, we have to also take LCM like we have taken upper LCM of 8 60s are 484. We have the remainder become 4 here because 8 60s are 480 and 4 remains, so remainder will be 4. And now here becomes 60, we have also taken LCM. 8 7s are is 56, so 56, remainder is also 4. We have to always take these values from there to up, so we write in answer 7 4 4. So it is seen that decimal is converted into octal number system simply. Now if we have a problem of point decimal number system after a decimal number system, like if we have the conversion of 484.281, so after the point is solved after like multiplying it, as we done in decimal to binary number system, multiply 8 by all this value, we have the answer is this. After the point value is taken as remainder always, as 2 is taken in remainder in this, and we again multiply this, simplifying in 2 or 3 tries more. if the value doesn't repeats. If repeats, we will stop there. Now again we simplified this, multiplied this, and one taken 1 as a remainder after point 1 is remainder, and we again multiply by this and taken 7 as a remainder. So value will be written from up to down portion in this. So 217, this answer, their answer was 744744, and this answer was 217. So we see that we will write a correct answer 744.217 here, like this. So and now move to the binary to hexadecimal conversion. Now see, before the decimal point, like this, it is simply solved as 16, taking LCM by 16. We have remainder here 9, and after multiplying this 6. So always, I have told you earlier, it is written as this from bottom to the top, 669. And if we have the problem with decimal number system, after the decimal point it is multiplied by 16 each time until the repeated value doesn't repeated value occurs, or no, if not, we will make 2 or 3 tries. Like in this situation, repeated value not occurred, we have made 2 or 3 times, and we now simply multiply 16 by that value and take remainder as 1, and this value by 16 and take remainder as 14 and 15. Now as you know that 14 is denoted by E and 15 is denoted by F in hexadecimal number system. So answer will be 1EF after the decimal point, like this. We merge it like 669.1EF. Now we have solved the decimal to hexadecimal number system conversion and moving to the octal to other conversion number systems. Now we have moved from to octal to binary number system conversion. Octal to binary number system conversion is simply easy, like this: 2 power 0, 2 power 1, 2, as I have told you earlier. After the decimal point or before the decimal point, it will be same as the pair of 3. And now for this, like this 7, we will merge to take 7 as 4 plus 2 6 plus 1 7. So this all will become 1 1 1. 7 pair will be made as 1 1 1. 6 will be 4 plus 2 6. There will be 1 1 0 as 1 1 0. Second pair of 6, 3 pair. Each number has three sub numbers in binary form as a pair. And after solving all this, decimal after the decimal, before the decimal, our answer will be this, and after point this will be this. It's simply conversion, it's not typical, like it's not difficult, it's a typical conversion. And moving to the octal towards decimal conversion. Now octal towards decimal conversion is simply, as we move to the octal to decimal conversion, here it's simply like we have taken an octal number 741, and after decimal, if we have to convert after decimal, if we have not to convert after decimal, it will become 741, and we have to simplify like this. After decimal, it will be simplified like this. This conversion is like simply solved into like this: 8 power before decimal it will be 8 power 0, 8 power 1, 8 power 2 multiplied by each of these values, and after decimal it will be 8 power minus 1, like this. And after simplifying that, it will become 481.4082. see, it's very simply converted into this, like we have studied earlier in binary to octal number system conversion. It is very simply, my real purpose is to teach you basic syntax of conversion, and it's very easy. Then now moving to the octal to hexadecimal number system. As you see, octal to decimal hexadecimal number system conversion, before decimal point we have to solve this conversion as like this, making 4 pairs of each, 4 pairs, because in hexadecimal number system I've told you earlier it will be 2 power 0 1 2 3 8 4 2 1, and 2 power 4 will be 16, which is not taken. So it will, in this conversion we will make pair of 4s like this. So simply convert this 1 into like 1, there will be 0 0 0 1 for that number. So here 0 0 1. Now for that 7 it will be like 4 plus 2 6 plus 1 7. So it will be 0 1 1. See as 0 1 1. Okay, like it is simply solved by making pair of 4 for converting octal to hexadecimal number system. As octal to hexadecimal number system conversion is not directly possible, we have to convert octal number system into binary number system first, after the decimal point and before the decimal point. Then we have to convert octal number binary number system into hexadecimal. Now it is converted into hexadecimal, as we have made the pair 9 and B. There we have the value 11. 11 is converted to B in hexadecimal number system. So octal is not directly converted to hexadecimal number system. Octal is converted to first binary number system and then hexadecimal number system. Now moving to the hexadecimal number system conversion. Now in hexadecimal number system conversion to binary number system, it's very simple. Like it is an example of hexadecimal number system which we have to convert it into binary. As D is denoted by 13 in hexadecimal system, B is by 11 and C is by 12, F is by 15 and F is by 15. This is simply in decimal form, and in hexadecimal this will be written as this. And now we have to convert it into binary. So we have converted that values into binary number system, as we have converted simply like decimal to binary number system. So hexadecimal is not directly converted into binary number system. Hexadecimal is firstly converted into decimal, then into binary number system. So we have studied earlier about decimal conversion into binary number system. It's very simple, and the answer will be that. So now for hexadecimal to decimal number system, it is so easy, not difficult conversion. Like if we have an example of with decimal point like this, after decimal point it will be taken 16 power negative values, and before decimal point it will be 16 power positive values, increasing 16 power 0 1 2 like this. Simply this is conversion hexadecimal into decimal number system. This is the example. And first of all we have to convert these characters which are in hexadecimal system into normal decimal number system numbers. So D is converted into this, and A is converted equivalent to 10 in hexadecimal. D is equivalent to 13. Now we have to convert this into decimal number system. So we have simply simplified this and got the answer by adding all these values. 54305.6337 in decimal number system. So see, it's simply converted hexadecimal number system's example into decimal number system. So it's very simple. Now moving towards hexadecimal to octal number system conversion. As you see, hexadecimal to octal number system conversion, we have simply taken this example of hexadecimal number system. We have simply converted these characters into hexadecimal equivalent digits. B is equal to 11, C is equal to 12 like this. Then we have converted by making pair of threes in binary form, hexadecimal into binary form, and then by this binary form is converted into hexadecimal into octal form. So hexadecimal is not directly converted into uh, octal form. It is firstly converted into binary form by making three pairs, and then it will converted into octal form. So this table will be easier for you all for these making solving these problems conversions, like it is simply allocated that binary is not directly see as hexadecimal. If we take hexadecimal system is not directly converted into decimal number system. It is firstly converted into binary and then decimal. So viewers, here are the example, and I hope you liked this video. Thanks. Okay.